Hey guys, welcome to a new chapter. This is chapter 9. We're starting with the first lesson, 9.1.1. All you have to do for these notes is follow along with me and copy down the problems and the steps as we work into your notebook. Okay, so what I'm doing on the screen, you're doing in your notebook. Make sure to get the problems down and the title. Okay, 9.1.1, what else can I solve? Solving quadratic equations. Also, try to be neat and organized because you will be uploading pictures of your notes to Google Classroom. Okay, let's start with the first problem. 9-1, use the zero product property to solve the quadratic equations below. We used the zero product property last chapter, and basically, when we have a quadratic equation and we set it equal to 0, we just need a factor, set each factor equal to 0, and then solve for x. So let's do that for part A. Problem, though, we have an equation that's equal to 9. So let's subtract both sides by 9 first so that we have a quadratic set equal to 0. And then now that we have this quadratic, we need a factor. So let's use a generic rectangle and a diamond to factor. Let's see, your x squared term goes here, constant term goes here. Multiply those two to get the top of your diamond, and the x term goes on the bottom. What multiplies to negative 45x squared and adds to 4x? That would be 9x and negative 5x. Put that back into the rectangle and find the length and the width. So 3x, x, 3, and negative 5. So you can rewrite 3x squared plus 4x minus 15 as the length and the width of the rectangle that we found. If you are wondering whether the order matters here, it does not. You can put x plus 3 first and then 3x minus 5. It doesn't change anything. Okay, now let's use a zero product property, ZPP. All you've got to do is set each factor equal to 0 and solve for x. So set 3x minus 5 equal to 0, set x plus 3 equal to 0, and solve for x. If you solve for x here, you get x is equal to negative 3. And if you solve for x here, you get x is equal to 5/3. I skipped over a couple steps, but we get 5/3, and I can leave my answer as a fraction. Okay, so we can move on to part B now. Part B has an equation that's set equal to 0, so that's perfect. And then it's also factored. The only thing is we have the 3, which is a common factor out front. That's not going to affect our answer in any way. We cannot set 3 equal to 0. That doesn't make any sense, so we're just going to ignore it. Just ignore it. Carry on as normal. Set this first factor equal to 0. Set the second factor equal to 0 and solve for x. Here we would get negative 3/2. And here we get x equals 5. Okay, perfect. For part C, it looks like we do have to factor. I'm going to factor out an x. That's a common factor here. X times x is x squared. X times 6 is 6x. So I did that quickly. I didn't have to use a generic rectangle for this specific problem. Okay, now let's set each factor equal to 0. Okay, x equals 0. That's one of our solutions. Since I don't have x plus anything equals 0, that's just my solution for x is 0. Set this equal to 0, solve for x. I get, I don't know how to make that go away. X equals to negative 6. Oops. Okay, we're done with 9-1. We've got a little refresher on the zero product property. So let's try to use the zero product property to do problem 9-3. 9-3 says solve x squared minus 6x minus 1 equals 0. Okay. Let's try ZPP, zero product property. We're going to take x squared minus 6x minus 1. And I'm going to try to factor first. So I need to draw my generic rectangle and my diamond and see if that's possible. Can we multiply two things to get negative x squared and add to get negative 6x? The answer is no, actually. This is not factorable. But because this is a new chapter, we have a new method for solving quadratics that result in this, okay? Before we would just say, oh, well, not factorable, we can't do anything. But this new method that we're going to use to be able to solve for x is called completing the square. And I'm going to walk you through it. Completing the square. Okay, let's take our quadratic. Very quickly, to make the steps solving for x easier later, I'm going to add 1 to both sides. I want to move this constant term over to the other side. So add 1 to both sides. That gets rid of that term on the left side. So all I'm left with on the left side is the x squared term and the x term. And then I have the constant term on the other side. Okay. Draw a generic rectangle. Here's what we're going to do. We need to figure out what term needs to go here. What number do I need to add to x squared minus 6x to be able to write x squared minus 6x plus whatever this number is as something squared? Here's what I mean. Let's use the generic rectangle as we've been doing. Put the x squared term here. We don't have this constant term. We do have the x term. Let's split this in half. What's half of negative 6x? That would be negative 3x. Okay, negative 3x plus negative 3x is negative 6x. That's perfect. Let's find the length and the width of this square. Here's why it's a square, because you have the same length and width. Okay, same length. Oops, it's not a pretty arrow. Same length, same width. So to complete this square, because squares have the same length and width, what does this term need to be? The answer is positive 9, because negative 3 times negative 3 is positive 9. Okay, so in order to complete that square, I just need to add 9 to x squared minus 6x in my equation. And remember that whatever you do to one side of the equation, you have to do to the other side. So if I'm adding 9 on the left side, I've got to add 9 on the right side. Okay, so let's take this equation and let's simplify a little bit. Let's add 1 plus 9, I get 10. Let's rewrite x squared minus 6x plus 9 something squared. What is that thing going to be? It's just the dimensions of the square that we made. Okay, x minus 3 times x minus 3 can be written as x minus 3 squared. Okay, how was I able to replace x squared minus 6x plus 9 with this squared? That's because I put it in the square, and I completed it. Okay, I'll do a couple of examples after this one so you can get the hang of it. But writing it like this helps me solve for x. Here's why. Because now I can take the square root of both sides and I get rid of that squared, that exponent. The exponent and the square root, they cancel. I'm left with x minus 3 here. square root of 10. I need to add plus minus here, indicating that the square root that we're taking can be positive or negative. Here's why. The square root of 9, for example, can be 3. It can also be negative 3, because negative 3 times negative 3 is 9. Okay, that's why I'm putting plus minus. It can be positive or negative. All right, we're almost done solving for x. If I just add 3 to both sides here, I get x by itself. I get x equals 3. Let me write it in green. 3 plus or minus the square root of 10. Plus or minus means that I can now do 3 plus the square root of 10 as one of my x values, and 3 minus the square root of 10 as another x value, okay? But having our solution for x like this is our solution in exact form, okay? It's called exact form because we have the square root in here still. So if you're asked to solve in exact form, you're done. If you're asked to solve in approximate decimal form, you've got to simplify a little bit. You've actually got to find what the square root of 10 is. The square root of 10 is about 3.16. So again, this plus minus means that you can do 3 plus 3.16, or you can do 3 minus 3.16. Here, you'd get 6.16. Here, you get negative 0.16. Okay, so these are our solutions in approximate decimal form. It's nice to have it in approximate decimal form because sometimes you're asked to graph a parabola, and if you know where the x-intercepts are, you know one is at 6.16 and you know the other one's at negative 0.16, it's easier to plot it. So this is the completing the square method. If you need to pause it, rewind, replay, do it. Do whatever you need to do, but you'll notice that over here for ZPP, we have nice numbers. They're nice fractions or they're nice whole numbers. Over here, that's not the case. We've got some not nice decimals, okay? There are exact vocabulary words for this when you have a whole number or a nice fraction. It's called a rational number. So think of like rational fraction. When a number cannot be written as a whole number or as a fraction, it's called irrational. Okay, so good to know moving forward. For the last problem that I'm going to work out in these notes, we're just going to keep practicing that completing the square method. So again, that first step that we took was moving this constant term to the other side because it makes my steps a little easier later. So let's add 3 to both sides. We're left with x squared minus 2x equals 4. Then I draw my generic rectangle and I put x squared in the lower left corner, and I take this x term and I split it in half. Half of negative 2x is just negative x, okay? Negative x plus negative x is negative 2x. Now I need to find the length and the width of this square. Notice I have x minus 1 for my length and x minus 1 for my width. That's why I'm calling it a square. And now I complete the square. What goes here? The answer is positive 1, since negative 1 times negative 1 is positive 1. So to complete the square, I need to add 1. So I add 1 here, and I add 1 on the right side of the equation too, because I've got to do it to the other side if I do it to the left side. Okay, let's simplify. X squared minus 2x plus 1 equals 5. Okay, I just combined the 4 and the 1 to get 5. And now let's rewrite x squared minus 2x plus 1 as something squared. What is that something going to be? Well, it's going to be this length here. Okay, x minus 1 times x minus 1 is just x minus 1 squared. Okay, if you look at what's inside of this squared, that's what this sum is. Okay, so I'm just rewriting the sum as a product. All right, now that we have this, we can solve for x. Let's take the square root of both sides. The square root and the square cancel. I'm left with x minus 1 on the left side, plus or minus the square root of 5 on the other side. Again, that's because when you take the square root of a number, you can get a positive or a negative. All right, let's add 1 to both sides. Now I get x equals 1. Where did it increase? 1 plus or minus the square root of 5. Again, this is my answer in exact form. Let's keep going a little bit to get the answer in approximate decimal form. So the square root of 5 is about, I need to do this on my calculator. Give me a second. Square root of 5 is about 2.24. So this means that I can take 1 plus 2.24 to get one of my solutions, and I can also do 1 minus 2.24. When I add, I get 3.24. When I subtract, I get negative 1.24. Okay, and this is my solution. These are my solutions, I should say, in approximate decimal form. All right, one more example, and I'm hoping that this is starting to make a little bit more sense. Okay, I'm going to take a quick water break. Okay, I'm back. For part B, we've got some really big numbers here. 840 and 238. What I can do is start by dividing all of the terms by 8 to make my life a little bit easier. So let's do that. I've got 8. Here I get x squared plus 5x equals that would be 29.75. Okay, again, let's draw our generic rectangle. Put your x squared term in the lower left corner. Take your x term and split it in half. Half of 5 is 2.5. So 2.5x plus 2.5x is 5. All right. That makes this x plus 2.5, x plus 2.5. So what should go here to complete this square? That should be 2.5 times 2.5 is 6.25. So I need to add that to both sides of the equation. I didn't leave enough room up there, so I'm going to rewrite it. Plus 6.25 plus 6.25. Okay, if I simplify, oops, I get 36 here. 36? Yeah, 36. Okay, now let's rewrite x squared plus 5x plus 6.25 as the length of that square squared. Okay, notice that for my square I have, oops, excuse me, x plus 2.5 times x plus 2.5. So this is going to be x plus 2.5 squared. Now I can start solving, take the square root of both sides. These cancel. I get x plus 2.5 equals plus or minus the square root of 36 is 6. Okay? Subtract the 2 over to the other side of the 2.5. I end up with x is equal to negative 2.5 plus or minus 6. Because there is no radical here, no square root, we can just keep going. Okay, this would be negative 2.5 plus 6 and negative 2.5 minus 6. If I add, I get 3.5, and if I subtract, I get negative 8.5. So in this case, this is my answer in exact form. It's in a decimal, but it's exact form because I didn't have to approximate anything. I'm not like estimating or rounding any decimals. This is exactly what it is. Okay, I hope this was helpful. If you have any questions after doing these notes, please send me an email or set up an appointment for a Google Meet video call. I have the sign-up sheet on Google Classroom. The last thing that you need to do for these notes is to just read through this straight from the book and copy this down on your paper too. Okay, so that's it. If you need to rewind, pause, fast forward, do whatever you need to do, but make sure that you get all of these notes on your paper and that you turn this in. Okay, have a great day.